Hello and welcome to this tech tip from Will. In this tech tip, I'll look at the difference between HyperV for Windows servers and Client HyperV for Windows clients. By the end of this video, you'll have a good understanding of the similarities and differences between the two products. So let's get started. First of all, let me start by giving you a high-level overview of both HyperV and Client HyperV. The HyperV feature essentially comes in two different flavors. The first of these is HyperV. HyperV is the original version of the product. HyperV has been around for a while, since 2008, and nowadays comes built into most modern 64-bit Windows Server operating systems. The next flavor is Client HyperV. Client HyperV was introduced later on in 2012 and is heavily based on the original HyperV product. Client HyperV comes built into newer 64-bit Windows client operating systems. Let's now take a closer look at the original HyperV product. The original HyperV feature was first introduced alongside Windows Server 2008, and it was designed as a native hypervisor. The reason why I say alongside is because when Windows Server 2008 was first released, HyperV was not yet fully completed. HyperV was later added to Windows Server 2008 as an optional download. More on that in a moment. Since its initial release, HyperV has been included with every Windows Server operating system released since, including Windows Server 2008 R2, Windows Server 2012, and Windows Server 2012 R2. To use HyperV on Windows Server 2008, you have to be running the 64-bit version of the operating system. This is because HyperV requires a 64-bit processor. Although it is possible to install the HyperV management tools onto 32-bit versions of Windows Server 2008, the HyperV feature itself cannot be installed. What's more, you have to be running either the standard, Enterprise or Data Center editions of Windows Server 2008. As I mentioned earlier, HyperV was not included in the initial release of Windows Server 2008. HyperV was released later on as an optional download. To obtain the HyperV role, the administrator is required to download and install Windows Update KB 950050. This update contains both the HyperV role and the HyperV management tools. Starting with Windows Server 2008 R2, the HyperV role was actually shipped with the Windows Server operating system. What's also worth noting at this point is that, beginning with Windows Server 2008 R2, Microsoft started to release their server operating systems in a 64-bit only architecture. This made the process of installing HyperV much simpler, since the administrator no longer had to worry about whether they're using a 32-bit or 64-bit operating system. To use HyperV on Windows Server 2008 R2, again, you have to be running either the standard, Enterprise or Data Center edition. With Windows Server 2012 and Windows Server 2012 R2, HyperV was once again shipped with the operating system. To use HyperV, either the Standard or Data Center edition is required. There is no Enterprise edition of Windows Server 2012. Regardless of which server operating system you choose, once HyperV is installed, the administrator is able to create virtual machines. Understand, when HyperV first made its debut, it was only available for Windows Server operating systems. You couldn't run HyperV on any Windows client operating system. In other words, if you wanted to use HyperV, you essentially had no choice but to purchase a Windows Server operating system. With the release of Windows 8, however, this all changed. Starting with Windows 8 and continuing with Windows 8.1 and now Windows 10, Microsoft has started to include HyperV with the client operating systems as well. However, this version of HyperV is referred to as Client HyperV. To use Client HyperV, you have to be running a 64-bit version of Windows 8, Windows 8.1 or Windows 10. Just like with HyperV, you cannot use Client HyperV on any 32-bit operating system. Furthermore, you have to be running either the Professional or Enterprise editions of the operating systems. You can't install Client Hyper-V onto any of the Home editions. Now that you have a high-level understanding of where Hyper-V and Client Hyper-V came from, let's now take a closer look at the similarities and differences between the two products. First of all, it should be pointed out that, under the hood, Hyper-V and Client Hyper-V were developed using the exact same virtualization technology. This is all very well, but it does beg an important question. If Hyper-V and Client Hyper-V are exactly the same under the hood, then what exactly is the difference between the two? This is a good question, so let's have a look. When comparing Hyper-V to Client Hyper-V, there are essentially two main differences. The first difference is that Hyper-V and Client Hyper-V are meant for use in totally different environments. In other words, there are times when the administrator should use Hyper-V, and likewise there are times when Client Hyper-V should be more appropriate. The second difference relates to the feature sets for the two products. That is, there are certain features which are included with Hyper-V that are not available in Client Hyper-V. Let's take a closer look at the differences. According to Microsoft, Hyper-V is fully intended for use on a production network. Client Hyper-V, however, is not. If the goal of the administrator is to deploy a hypervisor for the purpose of running virtual machines on a live production network, the correct way to do this would be to deploy a physical server, install a Windows Server operating system, and install the Hyper-V role. You should not use Client Hyper-V. Microsoft doesn't recommend Client Hyper-V as a hypervisor for running virtual machines on a live production network. In other words, Client Hyper-V should not be considered as an alternative to Server Hyper-V. So when exactly should you use Client Hyper-V? There are two occasions when Client Hyper-V should be used. The first is for the management of virtual machines. On a production network, although Client Hyper-V should not be used as the actual hypervisor that runs the virtual machines, it can be used to manage those virtual machines. To understand this better, consider the following. Imagine that you have a server running Hyper-V. This Hyper-V server is running multiple virtual machines. Elsewhere on the network, there's a computer running Windows 10. This computer has the Client Hyper-V feature installed. Using Client Hyper-V on their Windows 10 workstation, the administrator is able to remotely connect to the Hyper-V server and manage the virtual machines. The second occasion where Client Hyper-V should be used is for testing and development purposes. To better understand this, consider the following. Imagine a fictitious company called techtipsfromwill. Working at techtipsfromwill, there's a user named Carl. Carl is a software developer whose job it is to develop bespoke software applications for the company. Carl is assigned a laptop running Windows 10. On this laptop, Carl installs Client Hyper-V and creates 3 virtual machines. Carl has recently developed a new piece of software and wants to test how well the application performs on different Windows operating systems. So Carl installs a different operating system onto each virtual machine and tests the software. In short, Client Hyper-V allows the administrator to create small, isolated, virtualized environments on one physical computer. These isolated environments are perfect for testing new applications, software updates, and even network infrastructure changes. Now that you understand when Client Hyper-V should and should not be used, let's now take a look at some of the features that are missing from Client Hyper-V. Since Client Hyper-V was developed mainly as a testing platform, Microsoft decided to remove some of the more advanced Hyper-V features. That is, there are certain features available in Hyper-V that are not available in Client Hyper-V. When Client Hyper-V first made its debut in Windows 8 and Windows 8.1, 6 notable Hyper-V features were removed. These were Live Migration, Hyper-V Replica, Virtual Fiber Channel, Remote FX, 32-bit SR-IOV, and Shared VHDX. However, with Client Hyper-V for Windows 10, Microsoft has now added support for Virtual Fiber Channel, Remote FX, and shared VHDX. As such, there are now only 3 HyperV features missing from client HyperV in Windows 10, namely Live Migration, HyperV Replica, and 32-bit SR-IOV. This is all very well, but what exactly do these missing features do? Well, let's take a look. Let's start by looking at Live Migration. Live Migration was first added to HyperV in Windows Server 2008 R2. However, the feature was somewhat limited and could only be used with HyperV virtual machines that were hosted in a failover cluster. In Windows Server 2012 and Windows Server 2012 R2, Live Migration was improved and can now be used in non-clustered environments. Live Migration, in a nutshell, allows the administrator to move a running virtual machine from one HyperV computer to another HyperV computer. In other words, the administrator is able to move a virtual machine, which is set up and running, to a completely separate computer altogether, without having to shut the virtual machine down. With client HyperV in Windows 10, Live Migration is unavailable. To move a virtual machine to another client HyperV computer in Windows 10, the administrator has to use a different approach. One such alternative is the export feature, which is included with client HyperV. The export feature moves all of the files required to run a virtual machine to an alternative location, such as an external storage device, for example. This includes the virtual machine configuration files, the virtual hard disks, and any checkpoint data. Once exported, these files can then be imported onto another client HyperV computer. The next missing feature is HyperV Replica. HyperV Replica first appeared in Windows Server 2012 and was enhanced further in Windows Server 2012 R2. With HyperV Replica, the administrator is able to create a replica, that is a duplicate, of a HyperV virtual machine. This duplicate virtual machine is stored on another HyperV server. This is done for disaster recovery and fault tolerance reasons. To use HyperV Replica, at least 2 HyperV servers are required, a primary server and a replica server. The primary server hosts one or more virtual machines. When HyperV Replica is run for the first time, the virtual machine, as well as its virtual hard disk, is copied in full from the primary server over to the replica server. All of this can be done whilst the virtual machine remains up and running. When HyperV Replica runs again, only the changes made to the virtual machine are copied over to the replica server. With Windows Server 2012, replication of the latest changes will happen every 5 minutes. With Windows Server 2012 R2, the administrator can configure replication to occur every 30 seconds, every 5 minutes, or every 15 minutes. Periodic replication ensures that the replica server is kept up to date with the latest virtual machine changes. Should anything then happen to the primary server, the virtual machine on the replica server can be started up and will take the place of the virtual machines on the primary server. With client HyperV in Windows 10, the HyperV replica feature is not included. The last missing feature to discuss is SR-IOV. SR-IOV, or Single Root Input-Output Virtualization, is a technology that improves network throughput for your virtual machines. At the same time, SR-IOV reduces the amount of CPU overhead on the HyperV host computer. This is achieved by allowing the HyperV virtual machine to bypass what is called the hypervisor network stack. To better understand how this works, consider the following. With any HyperV implementation, you first have the hardware layer. The hardware layer is essentially the hardware found in the HyperV host computer, including the CPU, RAM, hard disk space, and, most importantly in this case, the network cards. On top of the hardware layer, you next have the hypervisor layer. When HyperV is installed, the hypervisor is created for you. The job of the hypervisor is to manage the resources found in the hardware layer. And finally, you have the virtual machines. Now let's look at what happens when SR-IOV is not implemented. First of all, imagine that these virtual machines are each connected to the network. To connect a virtual machine to the network, the administrator needs to create what is called a virtual switch. Virtual switches are created from the physical network adapters found in the hardware layer. When a virtual machine is connected to a virtual switch, this puts the virtual machines onto the network. Now, the thing to remember here is that the virtual switch we've just created is an emulated device. In other words, it isn't a real physical device. Why is this important? Well, since the virtual switch is emulated, it requires the assistance of the hypervisor. That is, when network traffic arrives at the physical network adapter, this traffic is then passed on to the hypervisor. The hypervisor is then responsible for routing this traffic through the emulated virtual switch and working out which virtual machine it is destined for. Of course, the act of doing this will incur a performance hit and takes up additional CPU cycles on the HyperV host computer. This is where SR-IOV comes in. When network traffic arrives at the physical network adapter, the traffic essentially bypasses the hypervisor and is passed directly to the virtual switch and then onto the virtual machine. In other words, the hypervisor is no longer required to route the network traffic to the virtual switch and then onto the relevant virtual machine. This reduces the amount of CPU cycles required. This is made possible because when SR-IOV is implemented, SR-IOV will create what is called virtual functions. Each virtual function is mapped to a specific virtual machine. In a nutshell, when network traffic arrives at the physical network adapter, the virtual function is able to identify which virtual machine the traffic is destined for and passes it on accordingly. Of course, in order to use SR-IOV, you must have a physical network adapter that supports it. These kind of network adapters can be rather expensive and tend to be found in higher-end server systems, not in regular desktop computers. Because SR-IOV is a feature found in more expensive hardware, I would guess that this is Microsoft's logic for removing it for client HyperV. Well, that covers the difference between HyperV and client HyperV. In the next video, I'll show you how to create a Generation 1 virtual machine in HyperV. I hope that you found this video useful and informative. For more videos, be sure to check out our YouTube page. Many thanks, and we'll see you on the next Tech Tip.